Hi everyone, I'm Dr. Brad Musil and welcome to Lecture 6 of Logic and Critical Thinking. In this lecture we'll turn our attention to inductive reasoning or inductive arguments. The last two lectures we've been discussing deductive arguments in detail by way of our discussions of categorical logic and truth functional logic. And so in general, this section 2 of the course, we are discussing arguments in much more detail. Right? We were first introduced to the idea of arguments in general in lecture 3 at the very end of section 1, and then what we've been doing again in this second section is taking a much closer look at both deductive arguments, and then in this lecture again we'll discuss then inductive arguments or inductive reasoning. Okay, so that's the general game plan here for lecture 6. So what we will do then in the lecture itself is, I'll offer a very brief review of what inductive arguments or inductive reasoning, what that amounts to. Hopefully we already have a pretty good kind of impression of that given, again, lecture 3, and then also by way of our contrasting what inductive arguments are with deductive arguments. Hopefully you've have a good kind of grasp of what an inductive argument is at this point. But we will again I'll offer a quick refresher on that, and then we'll go into much more depth. Then we'll join the authors of the textbook and go into much more depth with respect to 4 basic types or kinds of inductive reasoning or kinds of inductive arguments you might come across. So we'll talk about analogical arguments, generalizing arguments, and there's actually different names that these are referred to as well, and we'll discuss those as we go through each of these. De-generalizing and then cause and effect reasoning. We'll go through each of those in turn, and in fact, we'll spend a lot of time on number 4 here, which in the previous edition, the 10th edition that I worked with, had an entire chapter devoted to it just in and of itself. So we've got a lot to go through, and specifically with respect to that, we'll talk about this idea of hypothesis, what a hypothesis is, because it's oftentimes related to this idea of cause and effect reasoning or cause-effect reasoning. And so we'll talk about ways that we go about forming, coming to these hypotheses that we have, and then also how we go about trying to confirm, figure out whether our hypothesis is true or not. Different ways we can go about trying to do that. So again, we'll talk a lot about number 4 in particular, but we'll go through each of these in much more in great detail. That's the gist again of what we'll be up to in lecture 6. I'll try to offer some examples. I think examples are particularly helpful in the second section, like we've been doing with deductive arguments when we went through those. I think examples can be very helpful when we're talking about a lot of what we're talking about with respect to inductive arguments. So I'll give you an example when it comes to argument from analogy. The first one we'll talk to here in a moment, right? I'll give you an example of that. So lots of examples, and that's the general game plan then for lecture 6. Let's go ahead and then dive in. So turning to slide 2 of the lecture notes, we'll start again by offering a brief overview of what we're dabbling with here, as opposed to the previous 2 lectures, right? In lectures 4 and 5, we discussed deductive arguments, deductive reasoning, where the person offering the argument or offering their reasoning, they think that their conclusion has to be the case. There's no exceptions. Now, they might very well be wrong in thinking that, and that's where our assessment comes in, right? But that's the idea, right, in terms of identifying whether it's deductive or inductive. When we determined it was deductive, right, there was that element of necessity. They thought that conclusion of their argument had to be the case. That's never the case when it comes to inductive arguments. Yes, the person offering the inductive argument thinks that the conclusion is pretty likely if they're offering what they think is a good argument, right, or a strong argument. Okay? They think the conclusion is likely to be the case, but they don't think that it's going to necessarily be the case. Okay? That's the differentiating feature here. So to review, as I do on the top of slide 2, I quote the 10th edition, what they say in the 10th edition, quote, inductive reasoning is used to support rather than to demonstrate a conclusion. And we evaluate an inductive argument as relatively strong or weak, depending on how much its premises increase the probability of the conclusion. Okay, again, there's never that element of necessity, okay, a guarantee or 100%, right? It's always this idea of, well, to be a little bit more likely or a lot more likely, never what has to be the case. And that was taken from 349 of the 10th edition. So I also mentioned at the bottom too, a quick reminder, one way to sort of, it's not a hard fast rule, as we'll see in a little bit with some of these examples of inductive arguments, but one sort of way to get an idea of whether what you're coming across is inductive or deductive is to look for indicator words. So if you see many, most, several, a certain percentage, right, those are the examples I cite on the bottom of slide 2 here, that's going to be indicative of an inductive argument as opposed to all or none or 100% or 0%. Typically though, right, because you can still come across, for example, the word all, even in an inductive argument. So it's not a 100%. Anytime you see all, it's a deductive. Anytime you see most, it's going to be inductive. But it's definitely helpful to kind of keep that in the back of your mind. And so one example of an inductive argument that would use all, maybe something like all my classes with him so far have been great. Therefore, it's probably the case that all of his classes are great. Okay, the person doesn't think it's 100% going to be the case, right? That all of his classes will be great, but they're basing it on the experience of all the classes they've had so far. Okay, so again, there was an example of an instance where all was used in an inductive argument, so it's not necessarily going to indicate a deductive argument. These aren't hard and fast indicators, but a lot of time they will, right? When you see many or most or several, that is going to signal inductive reasoning or an inductive argument is at play versus a deductive argument. Hopefully that didn't throw you too much of a curveball, pointing out that it's not a hard and fast rule, okay? Because it does work typically, right? Again, a lot of the time, this will, when you see all, it is going to be deductive. Okay, so that is the end of slide 2. Now, an important point I'm raising on slide 3, and they do reference this idea of the principle of total evidence through page 375 of the 13th edition. I don't think they spend quite as much time in our edition, the 13th edition, as they did in the previous edition I worked with, the 10th edition, on this idea of principle of total evidence and how that's a different affair than oftentimes what we're doing in logic. Remember, in logic, we are concerned specifically with logic, remember, as opposed to critical thinking in general. If you're doing logic, you're concerned with arguments, and in particular, right, the connection between the reasons given, the premises given, and the conclusion, and how strong is that connection, right? Never mind the truth of the premises and the conclusion, right? How strong, if we presume the premises are true, how well would that actually support the conclusion? That's what logic's concerned with. Okay, and they do mention this, and I want to spend some time, again, emphasizing this point, that a lot of times what we're up to when we're assessing the merit or the strength, at least, of an inductive argument, we have to be careful when we go about doing that, because it can be tricky a lot of times, especially when it comes to conclusions that are crazy, right, or seemingly ridiculous, that we know on the face of it are extremely unlikely. It feels weird sometimes to nevertheless call an argument for such a conclusion strong when that might be the case. And so this is such an important point, and I didn't have room here, given what I have for an argument from analogy, which we'll get to in a moment, that I used my previous board here to make this, or give you an example here. So, right, say someone said something like, yo, and actually I'll be using a lot of examples with Bill and Ted here. Say Bill says, yo, Ted, most dumb people are people you should rob, and your wife's husband is dumb. Okay, so we have a couple premises there. And then the conclusion is, Ted, you should rob your wife's husband. Okay, now, on the face of it, that conclusion, not very probable at all, right? We know it, again, on the face of things, given that if you reflect on it at all, you realize that his wife's husband is himself, right? So not very probable that he should rob himself, okay? Nevertheless, this is actually a relatively strong argument for this conclusion. If we again, what we're up to in logic, if we presume these are true, these premises, okay, then this is much more likely to be the case. And by the way, this is an example of what we'll get to in our third type of inductive reasoning here, de-generalizing, okay, or a statistical or inductive syllogism. Okay. So that's actually an example that would fit that. Okay. So again, what we're up to in logic is we are solely interested in the connection between these premises and this conclusion. Never mind if the premises and the conclusions aren't true, right? Provided these were true, would they in fact support this, or how well would they support it? Yes, they would support it, okay, strongly. So we would say we would identify this as a strong argument, even though, right, if we were concerned instead with principle of total evidence, we would say all things considered, that's not very probable at all, especially given a moment's reflection and realizing that it doesn't ever really make sense to rob oneself. Okay? So again, that is an example where I'm trying to illustrate that there's a difference in what we're up to when it comes to logic and analyzing the strength of these inductive arguments versus someone who's concerned with the probability that a conclusion or claim is true, all things considered, or what's known as the, considering everything, or the principle of total evidence. Okay. So again, that's what I am getting at on slide 3. So I say, keep in mind that, as the authors point out in the 9th edition, quote, we can have a relatively strong argument for a relatively unlikely conclusion. And that's exactly what we had here, right? That's a relatively strong argument for a relatively unlikely conclusion, all things considered. And then I mentioned again that the authors do, in our edition, the 13th edition, do reflect on this idea of the principle of total evidence on page 375. Okay. And what specifically is this idea of the principle of total evidence? It is, as I define at the bottom of slide 3, determining the probability of a claim being true, taking into account everything that's relevant. Okay. That's what we're doing when we're considering the principle of total evidence, or working according to the principle of total evidence. That, again, is a different business than logic, which, again, is the point we're making on slide 4. Logic is simply concerned with the connection of those premises to the conclusion. Okay. So this is the point they make on slide 10, or sorry, not slide 10, in the 10th edition on page 349, when they say, quote, gauging the strength of this or that argument that Mr. York is a Democrat is a separate order of business and does not require us to employ the principle of total evidence, end quote. So again, gauging whether or not this or that, this, for example, argument for this conclusion is a strong argument is a different matter than considering whether this is probable, all things considered. Quote, and this is from our edition, page 375, quote, when evaluating the strength of such arguments, don't confuse the strength of the argument with the overall probability that the conclusion is true. Again, that's from page 375. Okay, so that's our brief refresher on what we're up to with respect to inductive arguments, and specifically when we, what is an inductive argument, how do we identify them, and then what we're up to when we assess them. Right? It can be weird. Okay, remember, when you're assessing the strength of these or weakness of these inductive arguments, however you want to put it, you are only concerned with the connection of the premises to the conclusion, how well those premises support the conclusion. Never mind whether the premises and conclusions are true or not, right, or how likely they are to be true. So going back to this, right, the issue is that premise 1 is ludicrous. Okay. Who knows about premise 2, but okay, obviously this is crazy, which makes one of the reasons why then this isn't still going to be very likely, even though this is a very relatively strong conclusion, or relatively strong argument. Okay, this is nevertheless not going to be very likely because this is false. Okay, so if we were to then assess this for cogency, right? Yes, it's strong. Okay, but we want to go back then and analyze the premises. Are the premises in fact true? No, this is false, right? Most people that are dumb, or most dumb people, are not people you should rob. Okay? In fact, I'd be hard pressed to think of an argument for anyone you should rob. I mean, you could probably make one given some extreme circumstances, but you get the idea. False. Okay. So all things considered, right? We would also label this not cogent. okay, and realize that this still probably is not going to be very likely, even though, again, we would identify it as relatively strong. Hopefully, I was holding that so you could see it. Okay, so we've done our sort of, again, refresher on inductive arguments, talked about how to identify them versus deductive arguments, and then what we want to focus on, particularly when we're assessing the inductive arguments in terms of their strength. Okay, what we want to focus on, specifically the connection between the premises and the conclusion, never mind the truth of them, at least when we're doing the logic part. Okay, so now what we'll do, let's go ahead and turn our attention to each of these four types. Okay, we'll spend a lot of time on three. Won't spend a whole lot on this one just because it's relatively straightforward, or there's not as much to go through as compared to these other ones. But we do have a lot to unpack, so we'll just go ahead and move forward here. So turning to slide 5, the first type of inductive argument we'll come across is what you probably heard of this one, an argument from or argument by analogy, okay, or analogical reasoning. And by the way, inductive reasoning, it's the same thing as when somebody engages in inductive reasoning, right? We could kind of capture then from that reasoning process an inductive argument, okay, because they're coming to like a conclusion based on certain sort of evidence they have, right? That's what we mean by reasoning. Okay, so inductive reasoning, when we talk about inductive reasoning, we're talking about inductive arguments. Okay, so we're analogical arguments, or analogical reasoning. We mean arguments by analogy. We mean arguments from analogy. Okay, they're all the same thing. So I mentioned the general form on the top of slide 5, okay, where I say, right, premise 1, for example, might say X and Y both have properties or characteristics. So properties, characteristics, traits, however you want to put it. X and Y have all these things in common. Okay, say A, B, and C. All these are properties. They have A, B, and C in common. Okay. Then we know of X, right? So we knew of X and Y that they had all those things in common. And then we know of X that it has this other thing, which we call the feature, okay, or attribute of interest. And so then the person wants us to infer then that based on all the other similarities or things we know to be true of both X and Y, and given that X also has this feature or other attribute of interest, then they want us to infer that Y will also have that feature or attribute of interest. So let's go through an example that will hopefully help clarify that. Do I want to throw this example up here yet? Why do I have it all the way? Yeah, I think I do want to. Oh, yeah. So, okay. Actually, here's my example is up here. So, slides 6 onward, we go through some terminology, but I want to give an example through which then I will discuss the terminology that comes. Basically, slides 6, 7, and even 8, right? We're basically just fleshing out the various terminology or concepts that are involved in discussing and assessing arguments from analogy. So let's go ahead and work through an example. Okay, so we talked about the general form on the previous slide, slide 5. Here's a particular example, right? We have what I labeled generally X and Y. Here we have, in this particular example, Sarah and Susie, okay? And then we have all these things or traits or characteristics or similarities, things we know they have in common, okay? That's stated in premise 1. Now, it doesn't have to be this rigid, right? Maybe that comes second in whatever the person's saying, but you get the general idea here, right? The general idea is the person's pointing out, hey, look, these two analogs, the things being compared, in this case, Sarah and Susie, okay, analogs, they have all these things in common, okay? In this case, so let me read this sentence here. Sarah and Susie are sisters who both like math, the color yellow, horror movies, and computer programming. And by the way, envision dad saying this for whatever reason, right? And they're discussing, mom and dad are discussing these sisters and their prospective college courses for the next semester or something like that. And dad says, well, Sarah and Susie are sisters who both like math, the color yellow, horror movies, and computer programming. And he's a logic professor, otherwise he would never speak this way, right? And premise 2, he says, hey, we know Sarah loved logic, and so he wants to conclude, therefore, Mom, Susie will probably love it too. Okay, so that's the example of the argument from analogy, just reading through it. Okay, so then what I was starting to do here, right, fleshing out all these various terms, which is what I'm up to on slides 6 and 7. We have then terms of the analogy, or what are called the analogues, the things being sort of compared. Okay, so in this example, Susie and Sarah, we have what we refer to as, so in previous editions they called it the target analog. In this edition, I believe it was the conclusion analog. Basically, whichever comparison term is appearing in the conclusion, hence conclusion analog. Okay. Or previously they referred to it as the target analog because it's the target, the one we want to suggest it's true of. Okay. However you want to refer to it, that's Susie in this example. And then we have the sample or the premise analog, the one we know it's true of already. Right? Hence it appears in the premise, okay, or it's true of the sample, the thing we're dealing with already. Okay? We know it's true of the sample, okay, or the analog that appears in the premise. Okay? So that is the top of slide 6. We talked about similarities. Now, what is the feature? We want to be familiar with this idea of the feature or attribute of interest. Okay, same thing. We mean the same thing. So if you might see it referenced as the feature, you might see it referred to as the attribute of interest. It's again referencing the same thing. In this case, it would be loving logic, the idea or notion of loving logic. Okay. It's captured here and it's captured here. Oh, by the way, the similarities. I suppose I think I went through them, but just to be clear, right? What are the similarities? Well, being sisters, that's something to have in common. Liking math, liking the color yellow, liking horror movies, and liking computer programming. They have all these things in common. Okay? But as I mentioned, use the idea of feature or attribute of interest to note the trait or characteristic that we know is true of the premise analog or sample analog, and we're suggesting is true of the conclusion or target analog. Okay. So that characteristic, right, in this case would be loving logic, loving it or loving logic. Okay, so only use the feature or attribute of interest to reference that particular trait, not all these other traits, okay, or similarities. I think that's everything from slide 6. So again, a lot of concepts, but they're pretty straightforward, and they're even intuitive. Similarities. Well, that's all the things that are stated, the cases that are known to be true of both, right? Hence the similarities. Premise analog. They make it pretty straightforward, right? Premise analog. Well, the thing that's being compared that appears in the premise, right? Well, they both appear in one of the premises, right? But the other one that only or the one that appears in both, right, is the premise. In this example, the premise analog, and the one that appears in the conclusion is the conclusion analog. Again, pretty straightforward. The analogs in general, things being compared. And we might compare different courses. We can compare anything, really. Whatever it is we're comparing, those are the analogs. So in this case, it's, again, these sisters, Sarah and Susie. Okay. Turning to slide 7, and actually I think it's slide 8 where I reference and it appears down here, and I know it's probably, I don't know how well you can see all this. There's a lot up here. But down here we have this idea of attacking the analogy, okay, which I define and reference on page 8. And it just refers to the general strategy of trying to undermine an argument by analogy. Okay? So if one were to hear this argument from analogy and then say, but yeah, I know that they offer what's known as a contrary analog, well, then they are doing what's known as attacking the analogy. They're trying to sort of undermine the argument from analogy that's offered. And one way to do that is to offer what I just referenced, right? This idea of a contrary analog. So in this example, that's just one way you can, quote unquote, attack the analogy. We'll go into this in a little bit more detail now, right? This idea of contrary analog. So I guess first, let me start by defining a contrary analog, which I do on the top of slide 7. So this comes from the page 365 of the 10th edition. So a contrary analog is, quote, an analog that shares some of the attributes of the other analogs, but does not share the attribute of interest or the feature. And so as they point out in the 10th edition, also on page 365, quote, the existence of contrary analogs makes the claim stated in the conclusion of an analogical argument less likely. So going back to our example, right, imagine mom immediately responded, because moms are extremely smart and quick on their feet. And she points out, although if this were the case, you'd think dad would have already known this, particularly if he's a logic instructor, I think, as I mentioned earlier. But she comes in and says, look, or however, Sally, your other daughter, right, their other sister, is also their sister. Okay, so she shares that similarity and likes all those other things. Right, so she has all these similarities, but she hated logic. Okay, so a contrary analog completely, well, not completely, right? It's one of the best ways to try to undermine an argument from analogy, because it's saying basically, look, it's possible to have all these similarities and yet not have that attribute of interest or that feature. We have, again, so the contrary analog in this case that mom's astutely referencing is Sally, the third sister, who is their sister, likes math, likes the color yellow, likes horror movies, and likes computer programming, but took logic and hated it. So did not have the feature or the attribute of interest and shared all those similarities. So obviously that then is going to weaken the strength of the overall argument. The more contrary analogs we can provide, the weaker than the conclusion of that argument from analogy. Okay? Because we're showing, hey, it's possible to have all that stuff in common and not have that feature or that attribute of interest. Okay. So, real quick, I think I will, before I discuss logical analogies and this other kind of notion of a logical analogy, I want to say, a couple other ways you can attack the analogy, so to speak, right? And they're actually kind of hinted at in the example I provided, and this is something else I get into then on slide 8. But we won't actually move to slide 8 yet. I'm just going to reference some of these things. Look, you could point out, right? Yeah, you mentioned those similarities, but how relevant are they? Right? I mean, how relevant, for example, is liking the color yellow to a love of a course or a particular subject, right? Or, you could argue similarly, right? How relevant is liking horror movies? Okay, so that's the idea of how relevant are these similarities, and obviously, for the argument from analogy to be strong, you need to have relevant similarities alluded to. Okay? Or another way to go about attacking the analogy would be to provide, you might point out, well, yeah, sure, you have all the similarities, but what about all their dissimilarities? Right? They have all that in common, but Susie doesn't like science, whereas Sarah does. Sarah likes art, whereas Susie doesn't, and so on and so forth, right? You point out, well, these two sisters also have all these other things that are not in common, yet you're not pointing that out, Dad. So there's a lot of ways Mom could have attacked the analogy, so to speak. In this case, she just provided what should have been a very obvious contrary analog. Okay? And Dad can't believe it's possible because he should have known, right, if he had such a daughter and was a logic instructor. Okay, so now I want to discuss briefly this idea of how you can use a logical analogy to better illustrate or show someone that for example, their argument is fallacious or there's something wrong with their argument. So I think that's everything else I wanted to say, more or less. So I'm going to erase this. So again, we're talking about the idea of logical analogies. So suppose Bill says, so here we have Bill saying, and bear with me here, if the professor lecture was long and complex, just like this sentence, then it would be hard to follow and assess accurately. Wow, that is a long sentence, long and complex sentence. Okay, then he's not done. So he says, since we know his lecture was hard to follow and assess accurately, we can therefore conclude that his lecture was long and complex. Oh my goodness. Just like this sentence, and that was terribly long. Okay, Bill. Imagine Bill says this, and being the diligent students I know you are, or listeners I know you are, and what we discussed in our previous 2 lectures, hopefully you'll be able to identify this, right, as affirming the consequent. So Bill is basically saying, as Ted points out, so actually let me put this up here. Ted then responds, so I'm not going to write this up here, but dude, that's a fallacy known as affirming the consequent. So remember, affirming the consequent was if P then Q, and then they say, well, hey, Q, therefore P, right? So they want us, whoops, yeah. So here he's saying, if the professor lecture was long and complex, just like the sentence, then it would be hard to follow and assess accurately. Since we know his lecture was hard to follow and assess accurately, okay, Q, then he wants us to conclude, right, that it must have been long and complex. And this is pretty difficult to assess, which is why, or to sort of wrap your mind around, which is why then logical analogies can be so helpful. Okay? Because Ted comes in and says, yo, dude, this is a fallacy known as affirming the consequent. Let me give you a logical analogy. This has the exact same underlying form, okay? But it's much easier to see why it's, so it has the same underlying form. So what Ted's going to say, right, if it's invalid, then what Bill said has to be invalid because they have the same underlying form. That's the way in which it's a logical analogy. Okay? It's got an analogical form, right? The form is similar. Okay? So he says, it's like saying, if it's a dog, then it's an animal, since we know it's an animal, we can therefore conclude it's a dog. Oh my goodness. Okay, so this would probably be even clearer if we actually wrote it up here like a math problem. Okay, but right, it's like saying, so Ted's pointing out, it's like saying if it's a dog, then it's an animal, and we know it's an animal. That doesn't mean we can infer then it's a dog, right? We were told what we can infer if we know it's a dog, namely that it's an animal, but we can't infer anything just by knowing it's an animal. Okay, it might be a turkey, it might be a human, who knows? Okay, and so again, this is an invalid argument. So he's pointing out by an analogy how then Bill's original argument, which had the exact same form, why then it too was invalid, which again was a lot more difficult given the verbiage, a lot more difficult to know on the face of things or to see, whereas this one is a lot more obvious. Yeah, that seems more intuitively invalid, right? That it's problematic, whereas this one doesn't. So you can use what's known as a logical analogy to then point out, right, these sorts of problems with the arguments people are offering us. So hopefully that was helpful. So again, that was the bottom of slide 7. As they point out in the 10th edition, okay, you can, quote, show someone that an argument is invalid by providing another argument that is just like the first, but more obviously invalid, right? So it's clearer, right? Given in this case, much less verbiage, right? Hence it's a lot clearer that this is invalid. Okay, they both have the same underlying form. So if this one's invalid, this has to be invalid. Turning to slide 8, pretty much went through most of this, captured the idea, already erased it, of attacking the analogy in general. Okay. And talked about the different ways we can go about doing that, pointing out contrary analogs, pointing out dissimilarities between the analogs, right, that we know apply to the analogs, suggesting that similarities are irrelevant, right, the similarities alluded to are irrelevant. So that's slide 8. Let's go ahead and move on from arguments from analogy and move on to what they refer to in this edition. They refer to it as generalizing. Okay. As I mentioned on the top of slide 9, it's also known as inductive generalization or generalizing from a sample. We'll title this generalizing. Okay, so general form, such as I allude to on the middle of slide 9, such and such a percentage, right, of observed x's are y's, therefore the same percentage of all x's are y's. Okay, so we're trying to suggest that what we know is true of a sample of a population will be true of all of the population. Okay, we want to, the idea is we have license to infer that whatever is true of that sample is true of the entire population. So obviously there's going to be then ways to make that inference stronger, making the sample larger, for example. Okay, but we'll go through all this in much more detail. But the general form, again, you're suggesting, okay, that look, we know such and such is true of this percentage of x's that we're familiar with, and so we want to infer then that it's going to be true of all x's, right? This percentage is going to be applicable to all x's. Okay? So I think an example would be helpful. What I point out at the bottom of slide 9 is important. Oftentimes it's not realistic. We want to know something about a population. By the way, what's a population? As I point out in the bottom of slide 9, quote, any identifiable group of things. So they spell that out on page 371. So oftentimes it might be the case that we want to try to figure out what's true of a population or any identifiable group of things, but we can't practically, analyze and assess, and interact with all the members of the population. The best we can do then is assess a sample or a portion of that population, and then try to infer what will be true of the population as a whole from what we know to be true of the sample. Okay, that's the general idea of what's going on when we get this type of inductive reasoning going on, this idea of generalizing. Okay, so yeah, I think I want to put up my example before then we go through and kind of go through some terminology like we did for arguments from analogy or analogical reasoning. Let me put up an example again. Bear with me here. I know this takes some time, but I think these examples are helpful. So we'll use Bill and Ted again. So Bill says, I loved all of Socrates or Socrates' lectures for Intro to Philosophy and Ethics. So I'm sure I'll love all of his lectures. Okay, so what he's done is offered an inductive generalization, right? He's engaged in generalizing, right? This type of inductive reasoning. Okay? He's come to this conclusion that he'll love all of Socrates' lectures, and it's based on, right? So he's saying something's true of a population, or in this case, what's the population? All of Socrates' lectures, and he's basing it on, a sample, a portion of that population, specifically his experience of, Socrates' lectures for Intro to Philosophy and Ethics. Okay? So he's offered again generalizing, an inductive generalization, a form of generalizing reasoning here. Okay, and so we'll go through, and we already talked about what a population is. In this instance, what's the population here? It'd be all of Socrates' lectures. Okay, and again, the idea, since oftentimes it's not practical, or some instances when this is the case, right? It's not practical to analyze all members of the population. For whatever reason we're doing it, right? We analyze a portion, okay, which is known as the sample. The members of the population we already know something is true of, right, or that we have analyzed in some shape or form. So as I mentioned, that's basically what I mentioned at the top of slide 10. So the sample in this example would be Socrates' lectures for Intro to Philosophy and Ethics. Okay. So I did point out on the middle of slide 10, and they define this on page 373 of the text, that, and this is oftentimes, we don't do this when we engage in this kind of everyday generalizing, right? So Bill's not going to offer what we call a sampling frame, but when we're talking about scientific experiments which try to do this kind of thing, or you are more likely to see what's known as a sampling frame, where they will come in and more precisely define what exactly it means to be a member of the population. All right, so when you get that sort of clarification as to what a member of the population is, and moreover, what it means to have the feature or the attribute of interest, you've been offered a sampling frame, or what's known as a sampling frame. So as they define it on page 373, which I quote in the middle of slide 10, This is, quote, a set of criteria that make it clear for any specific thing whether or not it is a member of the population and whether or not it has the attribute of interest. Okay. And by the way, so this is more applicable to, again, like experiments, not everyday generalizing. But when you see in like a study, that's going to reference the sample size. Okay. So not really applicable to our everyday example here. Okay. But I just wanted to point that out. Okay. Oh, I forgot to put what Ted says in response. I'll put it down here. But he's basically, actually, I'll put it down right. No, we'll put it, let's scoot this over. So let me put, yeah, next term will be feature. What is our feature? Oh, yeah, so again, more applicable to sort of scientific studies, okay? But the feature of the attribute of interest in this case, right, is the thing that we're know is true of the sample, right, in a certain percentage, and we're suggesting is true of the population, okay, so as a whole. So in this case, it's Bill loving the lectures, okay, so it'd be loving the lecture, or something along those lines, okay, you get the idea. Now, Ted chimes in and says, but, dude, you haven't taken his logic course. So, what is Ted intimating here? You don't have a very representative sample, Bill, because there are related factors at play, right? That your sample doesn't adequately represent, right? It doesn't represent these related factors to the same proportion as the overall population, right? So the overall population of Socrates' lectures is going to include his logic lectures, which Ted's intimating aren't as loving, or that you're not as likely to love, right? There's something about them that makes this much less likely, right, that he'll love all his lectures. And so, again, not having that taken into account in his sample is severely problematic. Ted's pointing out your sample is biased in that sense. So that's what I get at. Where is it? So I start getting into that. Actually, that is then slides 11 and 12. So I mentioned what a feature is in the bottom slide 10. Okay. So then turning to, and we pointed out what the feature is in this particular example here. Okay. So then turning to slide 11, I already sort of referenced some of these concepts and what I just pointed out, right, with respect to TED, but we have what are known as related factors or variables. So as they define those on page 350 of the 9th edition, the author suggests, quote, these are factors whose presence or absence in the population could affect the presence or absence of the feature, okay, or variable or attribute of interest we're interested in, right? So whether or not this is included, right, that's going to affect, right, whether or not you'll love it. That's the implication of what Ted's suggesting here, right? So generally speaking, as they point out on page 350 of the 9th edition, quote, the sample should be as diversified with respect to related factors as the target population, and therefore also large enough to have that diversity, end quote. So we're shooting for a representative sample, which is, as they point out on page 352 of the 10th edition, a sample that, quote, represents a population accurately. Okay, so it's going to, again, have those related factors, or be just as likely to have all those related factors, the sample will, as if it's representative, as the population will at large. Okay. So in which case, as they point out, again, page 352 in the 10th edition, variables, quote, variables linked to the attribute of interest are present in the sample in the same proportion as in the population. So turning to slide 12, Ted's suggesting that, hey, look, your sample is biased, okay, because you did not have exposure to this type of lecture. Okay? The lectures that are in his logic course which is part of the overall population. So your argument's weak here, or it's at least problematic. So what is a biased sample? As they suggest on page 373 of the 13th edition, our edition, so again, this is topic slide 12, it's a sample, quote, in which variables that may be linked to the attribute of interest are not present in the sample proportion as in the population, in the same proportion as in the population of interest, okay, which is the case here. Hence, this is going to the 10th edition, page 352, quote, to the extent a variable is not present in the sample in the same proportion as in the population, the sample is biased with respect to that variable. So this sample is biased with respect to the variable of logic lectures, right, and not having them. And Ted's point is that's going to sort of taint your perspective then unduly of Socrates lectures as a whole. Right? You need to have this accounted for in your sample, is the suggestion. Okay, so to try to get a representative sample, a sample that's not biased in these kinds of ways, we shoot for as best we can, right? Ideally, we try to do, have a randomized controlled experiment where we come in and, randomly assign sort of people or whatever we're interested to different groups, and we can subject them to various things and so on, right? And that would be, again, that element of randomly assigning every member of the population, right? Where every member of the population has an equal chance of being in the sample as well. That's then going to increase the likelihood, right? Or will increase our confidence in the conclusions we can reach from such reasoning, right? If we are able to do that, right? Employ this random sampling of the population and if we're able to ensure that every member of the population has an equal chance of being assessed in our sample, well, then that's going to help reduce the chance of bias in our sample. Okay, so we want to try to do these things if possible. Now, again, in our everyday generalizing, that's not happening, which is why the authors point out that oftentimes the everyday generalizing we engage in, we ought to be very wary of it. Okay? Case in point, as Ted points out here, and this is an example you could come across in an everyday, back and forth or discussion. Okay? And it's problematic. So to define more clearly, middle of slide 12, that idea of a random sample, it's a sample, quote, that gives every member of a population an equal chance of being included. That's defined on page 373 of our text. Now, random variation refers to this idea that, look, even if you have a random sample, there's still going to be a chance that the sample you have unduly has whatever the feature is in a proportion that's not representative of the population as a whole. Even though you did as best you could, right, you took a random sample, there's still that due to chance, right, there's still that possibility that the feature or the attribute of interest is more or less present in the sample than it is in the population. And that's captured by, again, this idea of random variation, which I discussed in the bottom of slide 12. So that refers to the fact that the presence of a feature or features varies from random sample to random sample within a population. So even given a random sample of the population, there's no guarantee those demonstrating the attribute of interest in the sample indicate the true proportion of those demonstrating the attribute of interest in the population. Okay, so we can do as best we can, but there's still going to be that notion of random variation at play, that idea that we can't, no matter what we do, there's still that chance, right, that we can't properly capture the proportion of members of the population that have that attribute of interest. So the error margin refers to, quote, and this is the top of slide 13, so I'm quoting pages 358 to 359 of the 9th edition. So this is how they define the error margin there. They say, or they define it as, quote, the range of the random variation from sample to sample. Okay, so I like their table. Their table captures this on the top of page 374 of the text. So again, the error margin, no matter how big of a sample we have, from the population, no matter how big our sample is. And this is only true of random samples, actually. We can only be so confident, right, that the percentage of the sample that has the attribute of interest, right, that same percentage is going to be applied to the population at large. We can only be so confident of that. So, and again, that's captured by this idea of the error margin. So let me put up an example here. So let's say, and this is a nice kind of, some of the examples I'll give in a little bit, they will reference the gateway drug theory, where the idea that users of marijuana are like more likely to turn to hard drugs. And so I'm going to provide an example kind of along those lines, because we'll again discuss that down the road here. An example here to help illustrate again this concept of error margin, confidence level, and so on. So this plays off of, again, table 11.1, which is on the top of page 374. So let's say, right, and this is working with a 95% confidence level, or what is a confidence level as they define it? This is the middle of slide 13. This is from page 359 of the 9th edition. Quote, the probability that the proportion found to have the feature in question in any given sample will be within the error margin. So the sort of scientifically acceptable confidence level is 95%. Okay? And going along those lines, so they point out, right, the bigger the sample, the better. Okay, so as they say in the 10th edition, page 353, quote, at a given level of probability or confidence level, the larger the sample, the smaller the error margin for that sample. So all this stuff is going to be a play for our example here. So we're going to work with kind of what in scientific journals, again, this is kind of what's deemed acceptable. If you can be 95% sure that your findings aren't due to, chance. Okay, so how this works then is, so the table in table 11.1, as they point out, this is confidence level of 95%. So we can be 95% sure, and the science, the statistics behind this bears this out, right? We can be sure of this, again, assuming, as I point out, this is an important point somewhere here, that this stuff has to be, I think that's slide 14, this has to be, again, random. Otherwise, none of the science involved here, none of the math works, okay? But again, assuming that we're dealing with a random sample, okay, then all of this will be true mathematically speaking. If we have, let's say, a sample size of 250 people, okay, so again, we can look at this table, statistics bears this out, okay? If we want to, to be sure, 95% sure that it's not due to chance, then, okay, then we'll have an error margin of 6%. So what this means, okay, let me give an example then. So let's say our example is, let's say 42%. So we had a sample of 250, and we're interested again in the gateway drug theory, right? So let's say we analyzed heroin users, okay, and we took a sample of 250 heroin users. Okay, and we found that 42% previous to their heroin use, that is, let's say, smoked marijuana. Okay, so that's our example. So, given this, what we can then infer, given the statistics, right, we can be 95% sure then that 36 to 48% of all right, of the entire population. Okay. So again, if we're working with a sample size of 250, right, so we've interviewed 250 heroin users, randomly selected from all heroin users, and that's important, randomly selected, okay? And we found that 42% of that sample had smoked marijuana before using heroin. Then we can be 95% sure, given the error margin for such a sample size, we can be 95% sure that 36 to 48% of all heroin users, right, all members of the population, okay, not just the 250 we hold, that they smoked marijuana first. Right, so hopefully you're kind of getting an idea of how that works. Now, as I mentioned somewhere here, where I pointed out, right, the larger than the sample, okay, the smaller than that error margin gets, right? So as the table suggests, if we boost this to 500, okay, this goes down to 4. In which case, we can narrow that percentage even more, right? So if this is 4, then this would be 38 to 46%. Whereas if we decreased it, right, let's say we only had 10, that's a problem. Right? It's because we can only say with 95% confidence, right? Again, we want to work with this, being able to say that we're 95% sure it wasn't just due to chance, okay, what we found to be the case from our sample. Okay, well, if we only have 10 members of the sample, then we have an error margin of plus minus 30. So suddenly we go from 12 to 72%, right? So if our sample, I should, change this as well as I was doing that, right? So if our sample becomes 10 heroin users of all heroin users, then we find actually how that's not even a possible percentage, but you get the idea, right? Let's change that to 40. Okay. We could still infer something, right? It's just not nearly as, it's not, what we can conclude from it is something we're not nearly as confident about, right? We could say we're 95% sure that 10 to 70% of all heroin users smoke marijuana first. That is a huge range, okay? And probably not something we would even want to utter, okay? So anyway, that's an example. Hopefully that helps clarify, again, the concepts that are detailed on slide 13 as well as 12. So turning to slide 14, as I mentioned, it's critical that we bear in mind that for all this stuff, right, with respect to the science in terms of the statistics, for all that to apply, the sample had to be randomly selected, meaning that every member of that population had an equal chance of being selected for the sample. Otherwise, none of this applies. None of the math applies. Okay, that's slide 14. A lot there. Well, we went through a lot, but hopefully the examples work. Hopefully it makes some sense. So we'll go ahead and turn to then the third type of inductive reasoning we're going to detail, and that's de-generalizing, or what's also known as a statistical syllogism or an inductive syllogism. And it kind of works in the reverse direction, hence de-generalizing. Okay, so again, just to point out, this is, I would say, way more often referred to as a statistical or inductive syllogism. Okay, and also, as I pointed out at the bottom of slide 15, it's very similar to modus ponens, right? If X then Y, X, therefore Y, right? If it's a cat, then it's an animal. It's a cat, therefore it's an animal. But again, the difference here is that the person offering, right, the argument, it's not as definitive, right? They're basing it on limited experience, right? And so knowing that they're not going to, as I mentioned in previous lectures, they're not going to bet the farm or bet their life, so to speak, as they would on with a deductive argument. Okay, so just wanted to mention, as I do on the bottom of slide 15, that it is very similar to, again, a modus ponens deductive argument. But what we're up to here with an inductive or statistical syllogism or de-generalizing is inductive. Okay, so the general form, as I point out on slide 15, I'll give you an example here in a moment, is, look, premise one, right, would be such and such percentage of x's are y's, or most x's are y's. This is an x, so therefore this is a y. Okay. So I guess I will put this up here. So the general form will be such and such percent of x's are y's. Okay. Premise two, this is an x. So we're going to conclude this is a y. Okay. So obviously, the more x's that are y, the more likely or the stronger argument this would become for then this conclusion, okay, that it's also a y. So let's give an example real quick. Bill says, in my experience, most philosophers are dummier than a fifth grader, and Socrates is a philosopher. Okay. So then what's he want us to conclude? Oops. So, look, Socrates, oh my gosh, Socrates is probably dummier than a fifth grader. Okay. So look, we know most philosophers are dummier than a fifth grader. So most x's, so x's are philosophers, right? In this example. And y is dummier than a fifth grader. Okay. So such and such percentage, or most philosophers are dummier than their fifth grader. Look, this, or Socrates is a philosopher. So they want us to conclude, well, since most philosophers are dummier than their fifth grader and Socrates is a philosopher, well, then Socrates is going to be, dummier than a fifth grader. So that's an example. And how strong the de-generalizing is would depend then again on sort of how this is couched, right? Most, 99%, well, that's going to be pretty darn strong, right? Again, we don't care if that's actually true, right? If it were true, well, then it would really support this conclusion, right? If it's true that if we assume it is true, as we do when we assess the strength of an inductive argument, if we assume, when they say 99% of philosophers are dummier than a fifth grader, if we assume that's true and we assume Socrates is a philosopher, well then it's going to be pretty likely the case that he's dummier than a fifth grader. Okay, so that is a very, very strong, that would be a very, very strong, relatively very, very strong argument for that conclusion, that Socrates is dummier than a fifth grader. Okay, that is de-generalizing. Again, pretty straightforward, gave you an example. Not as many like terms or concepts involved when outlining that, so we will go ahead then and turn to the fourth type of inductive reasoning we'll discuss, and that's known as cause and effect or cause-effect reasoning. Again, there's all sorts of ways you could sort of capture this type of reasoning or this kind of argument. We'll reference it as, again, cause-effect reasoning. We'll reference it in general as cause-effect reasoning. There's a lot of things at play here, a lot of things we'll need to discuss here. As I think I referenced in the beginning of this lecture, in the previous edition I worked with, this had an entire chapter devoted to it. So there's a lot here to unpack with respect to this, okay? Which we'll go ahead and do. The first thing we'll point out in the top of slide 16, we'll I guess, reiterate, what we discussed in the prior lecture, and that there's a difference between an argument and an explanation. Okay, they're not one and the same, so they're distinct. We discussed that in chapter 2, or what would have been, excuse me, I believe lecture 3. And so they discuss this point specifically. The authors do in the 13th edition on page 48 of chapter 2, right? And then they point out, this is on page 382, then, that an argument and an explanation are distinct, and that an argument, quote, is intended to support or demonstrate a contention, while an explanation, again, simply seeks to clarify something. And we did hammer that point home already in lecture 3. And we gave examples of like the swimsuit. There he's in his swimsuit because he was swimming and so on. I gave an example with respect to that, so that might jog your memory if you've seen that video. So again, we want to begin our discussion of this type of reasoning by emphasizing that an explanation in and of itself is not an argument, and it never will be. Okay? But, and this is what I point out at the bottom of slide 16. Okay, explanations can and arguably, often do appear within arguments, either as one of the premises or as a conclusion. So don't make the mistake of construing an explanation for an argument or vice versa. But nevertheless, right, explanations can be involved in an argument. And so we'll kind of flesh that out. And that's actually one of the points of emphasis in the exercises for the chapter is distinguishing. I know in particular one of the exercises is distinguishing when an explanation appears on its own entirely versus when it appears as a premise in an argument versus when it appears as a conclusion in an argument. So that is make sure you have, you feel good doing that, right? That's the kind of skill you have. That is important with respect to this chapter. So again, keep in mind the telltale difference between an argument and an explanation, especially when they can appear so similar at times, is that with the argument, there is that element of the person trying to convince you of something, right? Where that's lacking in just an explanation, right? They're not trying to convince you something's the case. Oftentimes it's just obvious, right? And they're explaining why it is the case. Okay, turning to slide 17. In sum, as the authors put it, page 407, quote, causal statements can be conclusions or premises in arguments, but not entire arguments, end quote. So as the authors intimate in what follows, this is from 382, quote, we are concerned with reasoning used to establish cause and effect or causal statements. So granting explanations and arguments are not one and the same. Let's talk about arguments that involve explanations, right? Or this cause and effect reasoning, okay? And by the way, causal explanations are cause and effect statements, or causal statements, however you want to put it, right? That all means, again, the same thing. As they put it on page 42, the type of argument we're discussing here in type 4, category 4. Quote, this kind of argument in effect concludes that something is the case because it's the best or most likely explanation of something else that we're interested in, end quote. Right? So we're sort of inferring what the cause might be of an effect that we see, right, based on a certain sort of reasoning process, which we'll again outline here in more detail. So that was from page 42. And so when discussing that kind of reasoning process that's related here, we need to discuss this idea of a hypothesis, which, you know, most of us are familiar with this notion of a hypothesis, you know, and what a hypothesis amounts to. It's kind of like a causal statement, but not one that one's fully committed to yet, right? So it's a cause and effect statement that one is suggesting is probably true, right? But that one isn't committed fully to yet and is positing for further investigation. Okay. As the authors put it in our text on page 382, a causal hypothesis, quote, is a tentative claim, a statement offered for further investigation or testing, end quote. As they put it on page 402 in the 10th edition, quote, when you hypothesize, you aren't yet stating an explanation, you are offering what you think is a likely explanation, okay, end quote. And by the way, you might have heard this idea of the inference to the best explanation, or IBE for short. And that's just kind of inference to the best explanation. As they mentioned on page 402, that's, quote, general strategy for arriving at or forming the most likely hypothesis. So that just describes, in general, how we go about forming our causal hypothesis, or hypotheses in general. Okay? We engage in this sort of inference to the best explanation. Right? We try to figure out, by analyzing various related things, right, what's the most likely cause or causal explanation for whatever we're interested in, whatever effect we're interested in. And that process is known as, in general, inference to the best explanation, or IBE for short. Okay, so what we're going to do here at the end is then go through this in more detail, right? This idea, having this notion of a hypothesis, right, which is a causal sort of statement, a cause and effect relationship that we think is probably the case, that then we're proposing we ought to investigate further. Well, how do we go about forming those hypotheses in the first place? Right, we'll discuss those, and the author suggests, as we'll see in a moment, there's 3 basic principles at play. And then also, how do we go about not just forming them, but then figuring out whether they're correct or not, testing them, right? Whether it be informally or through experimentation, right? How do we go about figuring out whether or not our hypotheses are actually the case, right? Whether or not they're true, and whether or not we ought to be committed to them after all. Okay. So we'll discuss both, as I intimated on the bottom of slide 18, right? We form on the one hand, and then try to test and confirm hypotheses all the time, and so we'll look at both these processes in more detail in what follows. So I'll give you some brief examples of situations, right? This happens all the time, this general process of, like, we would do it almost even subconsciously, right? Forming and then trying to verify whether something's the case, right? Forming hypotheses. You know, why is there water? This actually is literally the case in one of my bathrooms right now. Why is there water appearing near the toilet on the floor all the time, right? And we analyze various things, right? We come up with a hypothesis, but then, so we form the hypothesis through a certain sort of process. And then we, you know, if that's not good enough, right? We need to figure out whether that's our conjecture or our hypothesis is really the case, right? Because we need to fix things in the case of a toilet that seems to be leaking, right? So how then can we go about confirming or rejecting the hypothesis? We'll talk about then the different ways we do that. But, you know, this sort of thing happens in an everyday sense all the time, right? I give you some examples then. Car won't start. I give you an example that I'm dealing with right now. Water on the floor of one of my bathrooms. You get an evil glare from a professor. We'll pick up on that example in a slide or two. A killer headache in the morning. Right? Why is it I have this killer headache? I don't usually get killer headaches throughout the morning. What could it be? This is so unusual. All right, so these sorts of things happen, right? And we're instantly interested in trying to figure out why. And so we engage then in this process of forming and then trying to confirm or reject hypotheses. Okay, so let's go ahead then and turn to a discussion then of forming causal hypotheses. Okay, so the authors suggest there's three basic principles when it comes to how we go about forming these hypotheses. Okay, so we'll go ahead and just list those here. So forming. So we'll just follow their lead and discuss these three basic principles. So this is slide 19. They have what they reference the paired unusual events principle. Okay, that's the first one. We'll go through common. And then well, I have a covariation principle or principle of covariation, however you want to put it. And of course, these are also referenced as differently in different editions of the textbook, and I'll mention that here in a moment. In fact, I would argue that you hear them referenced less often as these and more often as some of these other things, but more on that here in a moment. So these are the three we'll go through. In fact, let's go ahead and dive into the first one, paired unusual events principle, or what's also known, so John Stuart Mill, they mentioned this, I think, in the footnotes as they go through these different methods of forming hypotheses. This is what John Stuart Mill referenced as the method of difference, which is typically how I hear it referred to as. But what is this? Well, as they define it in the 10th edition, page 403 of the 10th edition, they say that, so what sort of principle is at play here? Think of it like this. Quote, if something happens that hasn't happened in similar situations, look for some other difference between the two situations and consider whether it might not be the cause. End quote. Makes sense, right? So going back to that instructor giving you that evil glare, right? So at the bottom of slide 20 in my example. So when your usually friendly instructor sends an evil glare in your direction, you analyze things and you form your hypothesis. This is unusual. He's usually pretty friendly. What else is different about what's going on right now? Well, I'm usually paying attention, but I've been texting my friends on the phone, right? So then you hypothesize that maybe what's causing that glare is you being on your phone texting your friends, right? So again, if something's unusual, look for something else that is unusual, and maybe it is the cause of what was originally the unusual thing. So another example, like killer headache. Well, did you have a lot to drink the night before? Maybe that would explain then your unusual headache if you had an unusual amount to drink the night before. So that is this idea of paired unusual events. Are there two things that are unusual, right, that are going on, in which case the one might explain the other, okay, or be the cause of the other. Then, turning to slide 21, we have the common variable principle, or what's also known as the method of agreement, or what Mill called in particular the method of agreement. That's the number 2 here. As they point out on page 383 of our text, quote, a variable common to multiple occurrences of something may be related to it causally. So they give the example, I think, of a lot of people in a city being sick, and then right, you're like, so all these people are sick. Is there something in common? Yeah, they all ate tacos, I think it was, or whatever, from a particular restaurant. Okay. Well, I'll give you another example at the bottom of slide 21. When a group of high-achieving honors students all bomb an exam, an instructor hypothesizes that it's due to a party he hears they all attended the night before. Right? So there's something that was in common, right, amongst all those instances of bombing the exam. And then turning for our third method to the covariation principle, turning to slide 22. This is what Mill called the method of concomitant variation. Okay. What is covariation? Okay, it's known as the covariation principle. Well, what's covariation? As they define it on page 384 of our text, quote, when a variation in one phenomenon is accompanied by a variation in another phenomenon. So the idea is, this is from page 404 of the 10th edition, quote, if an effect present in multiple situations is associated with or co-varies with some other phenomenon, then there may be a causal link between the two phenomena. So for example, if you this is the example I give you in the bottom of slide 22. If you routinely feel worse throughout the following day when you sleep less the night before, you might hypothesize that sleeping less causes you to feel worse the next day, right? So you could sort of, if you were to analyze, you know, happiness, right? You had like a scale, not at all, somewhat, lots, however you want to do it, right? Where that can kind of vary. And then you had another thing, right? Amount of sleep previous night. And then you can define it by, 6 hours, 7 hours, however you want to do it, right? And the idea is, if, you find your happiness, you're selecting somewhat or not at all on the nights in particular where you seem to, the previous nights where you would get 6 to 7 hours, and then you're selecting, you're really, very happy, lots of happiness on the nights where the previous nights where you had 8 hours of sleep. The idea is, well, then, hey, maybe there's some sort of causal relationship at play. Right? That might cause us to infer, hey, maybe there's some connection here. Okay. So turning to slide 23, some brief important notes here. It's worth pointing out, as the authors do a few times, there's no strict formula here, right? When it comes to forming a hypothesis, we kind of use, oftentimes, as I mentioned earlier, this happens so often when we're doing this, forming and then trying to confirm hypotheses. A lot of times this happens even like subconsciously, right? But there's no particular formula you employ, right? You're kind of using all these principles, if you will, and coming to these the hypotheses we do. Okay, that's the idea. So there's no strict formula per se. As they put it on 386 of our edition, quote, formulating a causal hypothesis involves weighing various considerations rather than applying one or more of the three principles according to a formula. And then, as they also sort of mentioned, it can be likened to diagnosing a medical condition, like a doctor, right, who has to diagnose what's wrong with a patient. So the effect is the ailment the patient's experiencing, and we want to figure out, the doctor wants to figure out what the underlying cause is. Right? So as they put it on page 406, quote, the diagnosis is the physician's causal hypothesis. So again, we can kind of liken what's going on in general here with what a doctor's up to in forming his or her diagnosis. And I think it's an important point. They make this, or at least I noted this from the 10th edition, page 407, as I mentioned on the bottom of slide 23. They note, quote, that the best diagnosis is not necessarily the one that explains the most symptoms. So symptoms vary in their importance. Okay, so certain things might matter more than others in trying to figure out what the ultimately is the underlying cause. Okay. Let's go ahead then and turn to slide 24, where we'll turn our attention from forming hypotheses then to confirming, or trying to, right, confirm them. Okay. So again, there are three sort of ways, if you will, that we can go about doing this. On the one hand, we have what we'll call randomized. Again, you can refer to this in slightly different ways, as they have throughout various editions of the textbook. What they call randomized controlled experiments in this edition. Think like scientific experiments. Oops. And then we have prospective, observational studies, and retrospective observational studies. Okay. So we'll go ahead and turn then to slide 25 and go through each one of these in more detail. We've already kind of referenced controlled experiments, talked about some of the science involved in them and some of the concepts, random variation, error margins, and so on. So we've already referenced a lot of that, right? And so some of what we're going to discuss here builds on that. So turning to slide 25, as I point out at the top, a randomized controlled experiment is so called because of the control we exert, right? Namely, our ability to draw conclusions scientifically, if you will, or based on statistics. That's due to our ability to have these random samples, right? And exert control in that sense. Control in the sense that we can better control for possible related factors, okay? Whereas if we don't have a controlled experiment, we're more likely to have a biased sample because we can't have random samples and in the process can't then exercise as much control over those possible related factors. So hopefully that kind of makes sense. But again, there's that sense that we control things insofar as we're better able to account for again these possible related factors that are at play. Okay. So I like the way that the authors in the 10th edition from page 503 from that edition, how they characterize kind of what's going on in a randomized controlled experiment. They suggest the following, okay, quote, it's an experiment designed to test whether something is a causal factor for a given effect. In such an experiment, two groups are essentially alike, except that the members of one group, the experimental group, are exposed to the suspected causal factor, and the members of the other group, the control group, are not. The effect must be found to occur with significantly more frequency in the experimental group for the suspected causal agent to be considered a causal factor for the effect. So, and again, that was from 503 of the 10th edition. Let's say we're interested in the gateway drug theory. All right, let's say, which, in case you're not familiar, the idea in general, now there's all kinds of variations, I'm sure, but that it's the idea that marijuana serves as a kind of a gateway for harder drugs, right? Or will lead to heroin, let's say, or harder drugs. So to simplify things, we'll just represent it with that, okay? So let's say we were interested in that. If we were to have a randomized controlled experiment, what we do is randomly sample, in this case, the population at large, right? If what we want to infer conclusions about the population at large, right? Meaning every human, right? We would have a random sample, right? And then we would subject, right, some of them to marijuana, experimental group, right? So this is our supposed, so to be clear, right, the hypothesis marijuana use causes heroin use, okay? Cause, effect, okay? Okay, so if we were to engage in or run a randomized controlled experiment, again, we employ random samples. We would have two groups, right? And that would be, so our samples, we would randomly assign them to the groups, right? An experimental group, which, let me put it this way, we would then subject to marijuana, right? They would use marijuana, and then our control group does not. And then we then analyze the difference then in heroin use. What percent used heroin from the experimental group, and what percent used heroin here? Right. So we would subject the experimental group again to the suspected causal factor, and then we assess both groups, the experimental and control group. Control group again was not subjected to the causal factor, and then we'd assess both groups, excuse me, for the percentage of the group that had the effect, right, who in this case used heroin. Okay, so turning to slide 26, I mentioned this already, okay, going through some of the concepts and important things to keep in mind here. These subjects, right, that we've drawn, right, they have to be randomly assigned, okay, to our experimental and to our control groups. Okay? Otherwise, how are we to know that the related factors at play related to potential use, heroin use? How do we know that they won't muddy the water, right? We have to randomly assign them so as to best ensure that those kind of factors are going to be equally distributed as much as possible. So again, a lot of this is captured in the terminology we already talked about with respect to experiments. So you want to know, as I point out in the middle of slide 26, be familiar with the various terminology that we've already covered, that we've gone through here as well. So all the stuff that's detailed on pages 373 to 375 and pages 395 to 397 in the text. By the way, the D is the difference, the observed difference in effect between the groups. So let's say, just for point of illustration, let's give some numbers here. Let's say 5% used heroin and 6% used heroin in this group. So the D would be, in this case, 1%. The difference in observed difference in effect, rather, right, is 1% between the two groups. Okay, and that's what I mentioned on the middle of slide 26. So be comfortable and familiar with both table 11.1 and 11.2. Okay, so those again get into confidence levels and how confident can we be when we have a certain observed difference in effect that we've given our experiment and we've come to observe this difference in the effect. Well, how confident can we be that that's not simply due to chance, right? And so again, 95% is the confidence level that's generally accepted. So as the authors pointed out, if you read a study and you don't see anything referenced in terms of their confidence level, then it's probably 95%, right? They're working with that. I think that's everything for 26. So I think that's everything I want to say about randomized controlled experiments. So we'll go ahead and move on to slide 27. And we'll keep our gateway drug theory example up here. So that'll be helpful then for our discussion of the second and third as well. So turning to slide 27, we'll discuss what the authors in this edition refer to as prospective observational studies. Right? We're not running an experiment. We're not exerting any control over what's happening. Instead, we're just observing. Okay, that's the impetus for us labeling it as such. Okay, this is also referenced as a non-experimental cause-to-effect study. Okay, you'll see that oftentimes in various literature, including the previous editions of the textbooks. So in this kind of study, how does this look? Now we know we're not going to be as confident in the conclusions we can draw from these two types of studies because we don't exert the kind of control, as previously mentioned, that we do in these. Okay, so that's an important thing to point out from the get-go. But having said that, a lot of times maybe this will be the only way we can try to confirm our hypotheses. Okay, and so they're still important and worthwhile, right? So, how do these work though? So as the authors point out on page 415 of the 10th edition, when describing prospective observational studies, or what they called at that time, non-experimental cause-to-effect studies, In such a study, quote, a group of people who have subjected themselves to a suspected causal agent are compared with a control group, supposedly similar people who haven't done so, in order to see if the frequency of a possible effect is greater in the first group. Okay, so when we're doing number 2 here, a prospective observational study, we take a look at people, right? We don't actually assign them to groups and then give some of them marijuana and don't give some others, right? We actually analyze people who just have, right, smoked marijuana, okay, or used marijuana, and then some that who have not, right? So our control here would be used marijuana. Whoops. Of course, we're not really. I mean, this might be kind of, I guess, misleading because we're not. How do I want to put this? How do they put it in there? Because you're not really experimenting on them. So to say that it's an experimental group, you're comparing one group of people who have just used marijuana. So let's say group 1, and then compare them with group 2, have not. The critical point is, the critical difference here is the direction, kind of, right? So with prospective observational studies, we start with the suspected cause, and we take one group who we know has used or engaged in that suspected cause, and we compare them. So we're really, in this type of study, we're focusing on this, if you will, okay? And we're comparing one group who has the suspected cause with another group who hasn't, and then we say, well, how many of you guys go on then to, use heroin, right? So again, maybe we find that 5%, or actually was it 6% the last, 6% used heroin, 5% used heroin. Okay. But the point is, we take people that have already done this themselves, and when doing a prospective observational study, we say, hey, you used the marijuana. That's what you said, right? And everybody in this group did. That's what they said, right? And then all you guys said you didn't. Well, how many of you guys also used heroin? 6%? Okay. Then how many of you guys also used heroin, right? You didn't use marijuana, but how many of you used heroin, right? So we'll compare those two different groups, beginning with this difference, right? One had the suspected or used the suspected causal agent, and the other didn't, okay? Before we turn into kind of the opposite, we want to point out what I mentioned in the bottom of slide 27, which they mentioned on page 415 of the 10th edition. And I already alluded to this earlier. Quote, such cause to effect studies aren't nearly as conclusive in their findings as controlled experiments, because one cannot be sure that factors other than the hypothesized cause are equally distributed in the two groups, end quote. Okay, so those related factors might be skewing things. Okay. So let's turn to slide 28, right, where we'll talk about retrospective observational studies. Okay, and this kind of works the other way. So what you'll also hear referred to as non-experimental effect to cause studies. So we're working the other way, right? So in this case, our groups will change, our original sort of groups that we use here, our direction here. So group 1, group 2. Maybe first I'll just briefly define it here. So this is from page 416 of the 10th edition. Here we quote, compare a group of subjects who have the effect with a group of subjects who don't, right? So in one group, they're going to have the effect. They're going to have used heroin, while the other group will not have the effect or will not have used heroin, in order to see whether the hypothesized cause is more prevalent in the former group. So going back to our gateway drug theory here example, group 1 then would be people who have used heroin, Group 2 would be not heroin users. Okay. So we started with the supposed effect in this cause-effect relationship. And then what we're going to say, so you guys used heroin, group 1, okay, and then group 2, you guys and gals didn't use heroin. Okay, now going back to group 1, well, how many of you used marijuana? And we find out, well, 92%, right, suspected cause. We're working backwards, right? 92% are marijuana users. Oh my gosh, whoops. Okay, versus maybe 91%. This just means marijuana users. Repeat what I have up here. So we analyze, we start with two distinct groups that are distinguished from via the effect, right? This group had the effect of using heroin, and this group didn't have the effect, right? They didn't use heroin. And then we see, right, the frequency of the suspected causal agent, right, given the gateway drug theory, right, this marijuana usage, and we figure out the frequency within both groups. Well, it turns out 92% of the heroin users were marijuana users versus 91% of the non-heroin users were marijuana users. And by the way, this would not, be significant, right? This would not help the gateway drug theory if there's such a minuscule difference. That is not a very big difference in the effect, or the D is not very significant here, right? But you might, what if it was way different, right? 1% or something like that. Okay. Well then, that would change things dramatically, right? Significantly. Okay. But again, this has, as I mentioned earlier, right, same issues as this, okay, which is what I'm pointing out at the bottom of slide 28 when I reference page 416 from the 10th edition. Again, quote, the problem here is that other factors, that might in this example be related to heroin use, okay, cannot be known to have been equally distributed amongst both groups. Okay. So that's the issue, again, with both these types of ways of confirming our hypothesis, is that we can't control the related factors like we can in an experiment, right? Randomized controlled experiment. Okay, we went through quite a bit there. Just to quickly rehash, we reviewed what inductive reasoning is in general, or what inductive arguments are in general, and then we went through in much more detail the four types of inductive arguments or inductive reasoning that we come across. I spent a lot of time detailing those, in particular cause-effect reasoning here at the end. We went through, various ways we go about forming these hypotheses that we're working with, and then confirming them as well, or trying to. Okay, so a lot going on here. So this concludes section 2 of the course. Without a doubt, in my humble opinion, the most difficult section of the course. So again, at the end of section 1, we sort of introduced arguments by way of lecture 3, right? But section 1 in general was kind of just introduction to our subject and to arguments in general. But then in this section, we've really, again, spent a lot of time detailing arguments and turning our attention to both types in particular. Again, lectures 4 and 5, we discussed deductive arguments at length. And then in this lecture, lecture 6, we've discussed inductive arguments. So this will wrap up then our discussion of arguments. And from this point forward, we'll move on to aspects of critical thinking that are more peripheral to arguments, right? Or that are important, right, as critical thinkers, but that don't that aren't related to arguments per se. Now they might make it more difficult to assess an argument, or they might come across as arguments. We'll talk about fallacies that things that come across as arguments but aren't really, right? But the point is, we're done at this point with our discussion of arguments. Okay, and the difficult things that we've discussed with respect to arguments. And so put on your thinking caps, for the quiz, the related homework and so on. But then after we complete the second section, after you've taken the quiz for section 2, you should be able to breathe a sigh of relief to some degree, because I think things do get easier, at least compared to, the things we've had to do in the last 3 lectures. So, previewing then what's on tap in the third and then the fourth sections of the course, for the second half of the course, right? In section 3, we're going to talk about, clarity, credibility, and rhetoric, things that are that a critical thinker has to be very much cognizant of when going about figuring out, what should I buy into and what shouldn't I? What are good points and what was just meant to appeal to my emotions and that sort of thing. So that's what we will discuss at length in section 3, and then in section 4, we'll talk all about fallacies, mistakes in reasoning, mistakes in critical thinking, if you will, in general. And we'll spend then lectures 10, 11, and 12, concluding the course by discussing all these different mistakes we can make in our reasoning process. So that's what we have to look forward to in the remainder of the course. Hopefully you've enjoyed the first half of the course, despite the difficulties involved, particularly in these last 3 lectures. But anyway, that concludes, again, lecture 6. By the way, I should have mentioned this a long time ago, but lecture 6 then correlates to chapter 11 of the textbook. So if you're taking the course, right, it's chapter 11. So here's the chapter 11 homework. Hopefully you found this lecture helpful. And again, when I see you again, it'll be lecture 7, where we'll talk about issues related to clarity. Thank you.